Hello everyone, this is PRAVEENKUMAR from IT third year G1. This is my submission for the event RECode 3 conducted by Coding Club of PhD College of Technology. They have given two problems. One is to choose a coding problem in the portal and create an explanation video for it. The other one is to select any one tool, software or libraries and create an explanation video for it. I solved the coding problem. Let's see the problem. The question is, given an integer array, we have to find the length of the longest increasing subsequence. Here is the explanation of the problem. Let's take an array with elements 1, 3 and 2. We have to return the length of the longest increasing subsequence. The possible subsequences are 1, 3, 2, 1, 3, 1, 2, 3, 2 and 1, 3, 2. Out of this, we have to find the longest increasing subsequence. The subsequence should be strictly in increasing order. If we take 1, the next element is 3, which is greater than the previous element. If we take 1 and 2, the 2 is greater than the previous element. So the subsequence should be in strictly increasing order. In this example, in the subsequence 1, it is only one element, so the length is 1. For the single element, the length is 1. If we take 1 and 3, the length is 2. It is in strictly increasing order, so we can take the length as 2. For 1 and 2, it is also 2. For 3 and 2, it is not in increasing order. If we consider this subsequence, it is not in increasing order, so we will not consider this subsequence. So the maximum length of the subsequence is 2, which is this, or 1 and 2. Let's consider another example. The longest increasing subsequence in this array will be 3, 10 and 20 with the maximum length of 3. The other subsequence will be 1 and 20, which is 2, or 2 and 20, the length is also 2. So the maximum length of the longest increasing subsequence is 3. So how can we solve this problem? The basic approach is to generate all the subsequences like this, and out of these subsequences we have to find the length of each subsequence in strictly increasing order and calculate the maximum out of this length of the subsequences. We can simply achieve this by recursion. We can generate all the subsequence by the relation either by picking or not picking the current element. So the time complexity by the recursion will be 2 power n. We can reduce the time complexity to n cross n by memoization, but the best approach is n log n, which is using the binary search algorithm. Let's see the binary search algorithm to find the length of the longest increasing subsequence. The idea is simple. Let's traverse an element through the array. Let's take the first element 3. Since it is the only element, so it is the maximum in the current subsequence. Next we take 10, which is greater than the previous element 3, and next is 2. The 2 is not greater than the previous element, which is 10, so we put it in the another array. And next we take 1 is also less than the element 10 and 2, so we separately put this in another location. Let's take 20 is greater than 10 and 2 and also 1, so the length will be 3, 2 and 2. Out of this, 3 is the largest element, so the length of the longest increasing subsequence is 3. But this takes a lot of space. Instead of writing it in another location, we overwrite the value 2 in the same location, which is 3. So we compute that using the new approach. Let's initially take 3 and the next element will be 10 and the next element 2 is lesser than 2 and the best position for that is 3, and let's take 1 is also less than 2 and less than 10 and less than 2, so let's overwrite this with 1. And next 20 is greater than 10, so we put it in the last, so the maximum length is 3. We get the same output. So we solve this using another example. First we take element 10 and next 9 is lesser than 10, so we overwrite this with 9, and the next 2 is also less than 9 and overwrite it with 2. Next 5 is greater than 2, so we add this in the same array, and 3 is less than 5. And 3 there is also an element which is lesser than 3, so 2 we overwrite this with 3. We overwrite in the correct position following in the same order. Next we take 7 is greater than 3, so we add this to the array, and 101 is also greater than 7, so we add this in the same array. Next 18 is less than 108 and greater than 7, so we overwrite the 108. So the array contains 2, 3, 7 and 18 with the length 4. So the length of the longest increasing subsequence in this array is 4. Approach is we traverse each element in the array. If the element is greater than the previous element, we add in the last of the array. If the element is less than the previous element, we find the best position so that the element of overwriting the element in the array maintains in the sorted order. If we overwrite the element 3 with 5, the previous element 2 is less than 3 and the next element 7 and 18 are greater than 3. So how to find the position to overwrite the element? This is done using binary search. The element is already in sorted order, so we can simply use the binary search to find the position to overwrite the element. For finding the position using binary search, it takes log n times, so we traverse each element n elements, so the overall time complexity will be n into log n. Let's see the solution for longest increasing subsequence using Java. We create an array list to store the element. First of all, initially we store the first element of array to the array list, so the length will be 1. We iterate through each element in the array. So the first element, if the element is greater than the previous element, last element of the array list, we simply add the element to the array list as you saw in the example, and we keep track of length for returning the longest length. If the current element is not greater than the last element of the array list, we find the position using binary search in the collection package. It returns the index. If the index is less than 0, the position will be, if the element is not found, the position will be the index return will be negative, so we convert into positive and decrement the index. If the index is greater than 0, we simply update the element at the index, and finally we return the length, which is the maximum. We took the example as we saw in the explaining. So if we run this, we are getting the answer 3, which is correct. Let's take another example, and if we run this, the maximum length is 4, which will be 3, 7, 40 and 80. That's also correct. So this is the solution using Java.